So here's our formula. We're calling the width of the initial rectangle, which then we turn into a right angle trapezoid, D, so that we can take the other rectangle that helps us form the right angle trapezoid. We can call its width A. Both of the rectangles have a height of B, and then C is just A squared plus B squared equals C squared. This length is D minus A, and then what we want to find here is what scale symmetry has it so that this is just one multiple of the scale symmetry, smaller than this one. So in the formula here, we show that with the power to 1. We can do any natural number power here up to n times 2. And then n is also the pi divided by number, and so that means the rotation. Instead of pi divided by, we can do 180 divided by, so that this right here is 60 degrees, and that's why the tangent is there. So here's that formula in Wolfram Alpha, and let's see how this works. So here's the original rectangle that we'll use to form our right angle trapezoid. Side D is 100. So let's change the width there to 100. And the height is 50 divided by square root of 3, which is this number 28.867. So let's change the height to that. Great. Next we make the other rectangle, and then find A. B we already know, since it's the same as the first rectangle. And A is relatively straightforward. It's just 50. So half of D here. So there we go. Okay, now we can use these two rectangles to make the right angle trapezoid. And here's how we make that trapezoid. And now we have the tile. The scale symmetry is just 1/2. So that's fairly straightforward. So we multiply by 1/2 to the power of 1. And then here we take the pi over n amount, or 180 over n. And we get 60 degrees. So there we go. We've got the tile now rotated, and we put it in place. We repeat this, and every time we're repeating it, from the right angle trapezoid we started with, we can track each step by having the next natural count on the powers to the scale symmetry. So since this is a geometric mean, we do power 1, power 2, now we're in power 3 here. 1/2 to the power 3. And we do this 6 times since the rotation pi over 3. So then the full circle is 2 pi, and so we multiply 3 by 2. And so we put 6 of these tiles in. So now we're up to 1/2 times to the 4th, pardon me, not times. And now to the 5th. So the next one would start from the same angle as the initial tile. And now we're adding the next layer down. So the D minus A equals amount, right? Since we set S to 1. So now we need to do 6 of these, just like we did 6 of the rotation. And once we get there, we'll see that that gap there is closed. And so now we have the repeating object of the repeating spiral loop, I guess we can call it. And yeah, so to start the repetition again, we do 1/2 to the 6th. Fire. There you go. We can repeat this infinitely, at least in a Platonic ideal. All right, so now we're going to do another version, but instead of setting S to 1, so we have to do those 6 repetitions before we close the gap. We're going to set it to 3, so then we only have to do 2 repetitions. So let's see how this goes. B is a little more complicated here than the original one. So same process as before. But B here is very different. It's much, much wider. And of course, another way to think of this is our original tiling, but with the first 3 loops included. All right, now we have the 2 rectangles to make the right angle trapezoid. And as you can see, D minus A is much shorter than when S was set to 1. And we do 5 rotations here, with the original one being the 6th, or the 0th, however way you want to look at it. All right, so we have that now. And unlike last time where we had to do all 6 loops because we set it to 1, now we just have to do 2 loops. So we already have the first loop here, and we see we're counting the powers there. And so we've got 0.5 to the 6 as that begins the loop again. And this time, actually, we're showing how we can continue just with the continue the spiral with infinite loops. And so with this, yeah, now we're doing the second layer. And we have to do it to the power of 3. But there you go. We've closed the loop.